Hello friends, in this video we will learn the theory of an NOR gate and we will design it on breadboard. Here is the logic symbol of a NOR gate. A NOR gate has two input terminals and one output terminals. There are also NOR gates more than two input terminals. Here we have considered the input terminals as A and B and the output is A plus B bar. That means for a NOR gate the output is always the opposite of OR gate. That means we will get the inverted output of an OR gate, because the symbol you can see this one is OR symbol and then a NOT is present. Here is the truth table of a NOR gate. From this truth table we can see when we apply 0 at terminal A and 0 at terminal B, the output is 1. So for an OR gate this output was 0. Similarly, when we apply 0 at A, 1 at B, then the output is 0. That means the output is always the inverted output of an OR gate. Here is the IC number of a NOR gate 7402. Here is the IC diagram of a NOR gate. From this IC diagram, we can see that a NOR gate IC has 4 NOR gates 1, 2, 3, 4. So here is the first NOR gate. Pin number 2 and 3 are the inputs of this NOR gate and 1 is the output of this first NOR gate. Then the pin number 5 and 6 are the inputs of the second and 4 is the output. Similarly like this. For this NOR gate IC we can see pin number 7 is ground. That means we have to connect it to negative terminal of our battery, and pin number 14 is always VCC for a NOR gate IC. So we have to connect it to positive terminal of our battery. So we will implement it on breadboard now and we will observe the output. Here is a NOR gate IC 7402. When we keep this IC like this by keeping this cut mark to the left side, then the first pin will be pin number 1. That means this is 1, 2, 3, 4, 5, 6. Then this last one is 7. Then 8, 9, 10. Then this one is 14. So we have to first insert it into the breadboard. So we will first insert it. Then we have to connect the pin number 7 to ground. We will connect it to this row here, because we will use this row as ground row. We will connect the negative terminal of our battery to this row, and we have to connect this pin number 14 to VCC. We will connect it to this row from here to here, this row, and we will connect the positive terminal of our battery to this row. Then we will connect two wires at the input terminals, that is at 2 and 3. Here is pin number 2. We have connected this red wire, and here is terminal 3. Then we will connect an LED at the output terminal, that means at 1. So for this LED we have to use a 100 ohm resistor. So we will connect any one of the terminal of this resistor to pin number 1, and we will connect the another terminal to any point of breadboard. Then from that point we have to connect the positive terminal of our LED. We have used a red LED to observe the output, and the longer one is a positive terminal. That means we have to connect it to this terminal of the resistor, and we have connected the another terminal to any point of breadboard, and from that point we have to connect it to ground. So we have connected it to our ground row. So now our circuit is ready. Now we have to connect a battery. We can use any battery from 4 volt to 6 volt. You can also use this type of battery, that means 9 volt battery, to our circuit, but it may damage the IC, because the recommended voltage for this IC is 5 volt. But we can convert this 9 volt to 5 volt or lower volt by using different techniques. If you don't know, then you can watch our video how to convert 9 volt to 5 volt. The link of this video is given in the description of this video. So we will connect this 4-volt battery directly to our circuit. So we have to connect the negative terminal of our battery to our ground row that we have considered. So we will connect it to ground and positive terminal to this VCC row. Now we will observe the output. Now from this truth table we can see when A is 0, 0 means we have to connect it to this ground row, and when B is 0, 0 means we have to connect it to ground. So then the output should be 1. That means the LED should turn on. So here the LED is now on. So when A is 0, 0 means we have to connect it to ground. It is already connected to ground. And B is 1, 1 means we have to connect it to VCC row. So you can see the output is now 0. The output is 0, that means the LED is now off. Then when A is 1, 1 means we have to connect it to our VCC row, and B is 0, 0 means we have to connect it to ground row. In this case also the output is 0, the LED is now off. For the last case, when A is 1, B is 1, that means we have to connect both the wires, that mean input terminals, to our VCC row, and in that case also the output is also 0, that means the output LED is also off. So the truth table is verified. So thank you for watching this video. If you like our videos, then please don't forget to subscribe to our channel, and you can also buy electronics components, projects, sensors, modules from our website www.dpvtechnology.com.